The first named storm of the season has not even peaked, and it is already forecast to do the impossible twice: survive a journey across the entire deep south, and then come back to life off the Carolina coast days after it should be gone. Forecasters say tropical storm warnings may be needed there by the end of the week. Arthur is a small storm carrying a big warning. In the next few minutes, you will understand how it reloads over land, why the Gulf is this warm this early, and what it tells us about the season ahead. Yesterday, the National Hurricane Center named Tropical Storm Arthur the first named storm of the 2026 Atlantic season, as it organized over the northwestern Gulf near the upper Texas coast. On its own, that would be routine. Arthur is a weak storm. Its winds are modest, in the range of 40 to 50 miles an hour, and it is not going to be remembered for its strength. What it may be remembered for is what it is forecast to do next, because the models meteorologists trust most are showing this storm doing something a tropical system is not supposed to be able to do. They are showing it getting stronger over land. Here is the rule everyone learns about these storms. Land kills hurricanes. A tropical system is born over warm water, it feeds on warm water, and the moment it moves ashore and loses that water, it starts to fall apart. That is the textbook, and it is right almost all of the time. The original forecast for Arthur followed it exactly. Reach tropical storm strength near the coast, then weaken to a depression as it moves inland. Standard, forgettable, expected. That is not what the models are showing anymore. They are showing Arthur holding together as it crosses the deep south today, and then, days from now, re-strengthening as it reaches the Carolina coast, possibly deepening into a low under 1,000 millibars as it slides back over the open Atlantic. A storm that should be dead by Thursday could have organized circulation again by Friday. There is a name for how a storm pulls this off, and the conditions for it are lining up right now. To understand why this matters, you first have to understand why it should be impossible, and it gets stranger from there. A hurricane is not really an object. It is an engine, and like any engine, it runs on fuel. The fuel is the heat stored in warm ocean water. When the air sits over a sea that is warm enough, water evaporates constantly, and that water vapor carries hidden energy upward into the storm. As the vapor rises and condenses into thunderstorms, it releases that energy as heat, which warms the core, lowers the pressure, pulls in more air, and drives more evaporation. Around and around it goes. That cycle is the entire secret of how a tropical storm builds and sustains itself. Now you can see why land is supposed to be fatal. The instant a storm moves ashore, the warm ocean is gone, and the fuel line is cut. The ground cannot evaporate moisture into the storm the way a warm sea can. On top of that, the land fights the storm in two more ways. The rough surface of the land, with its hills and trees and terrain, creates friction that tears at the storm's winds, which spin most efficiently over the smooth, open ocean. And the air over a continent is often much drier, and when that dry air gets pulled into the storm, the thunderstorms collapse from the inside. Cut the fuel, add friction, pull in dry air. That is how a tropical system normally dies, and it usually happens within a day or two of landfall. So when a storm refuses to follow that script, when it holds together and even strengthens over hundreds of miles of land, there are only two possibilities. Either the rule is wrong, or something on land is feeding the storm in a way we do not usually think about. And there is, in fact, something that can do exactly that. The mechanism is called the brown ocean effect, and the name is the clue. We think of the ocean as blue, the warm engine that powers a hurricane, but scientists studying storms that survive inland realize that, under the right conditions, the land can act like a shallow, muddy, brown version of that ocean. It can do the ocean's job. It can hand the storm the same hidden energy, the same latent heat. With the blue ocean hundreds of miles behind it, it works like this. When the ground is soaked with water and the sun heats that saturated ground, the water evaporates and lifts hidden energy upward exactly the way a warm sea does. Researchers generally point to three conditions that have to line up. The lower atmosphere has to stay warm and tropical, with little variation. The soil has to be extremely wet, and that waterlogged ground has to release its moisture upward as heat, feeding the storm. When all three are present, soaked land under a summer sun stops acting like a brake and starts acting like a fuel tank. Think about what that means physically. When the sun beats down on a flooded field, the water evaporates and lifts hidden energy upward, the same hidden energy a warm sea provides. Over dry ground, there is not enough moisture in the soil for that to matter, so a storm passing over it starves. But over ground, turned into a shallow reservoir, soaked through and warm, the evaporation gets close to what you would get over the ocean itself. The land hands the storm the fuel it needs. And the reason this happens in June specifically is that you need strong sunlight and heat to drive that evaporation, which is exactly what early summer delivers. A waterlogged deep south under a high June sun is, in a real physical sense, a shallow warm sea spread across the land, and Arthur is about to drink from it. Now look at where Arthur is going. It is not crossing a dry continent. It is crossing a deep south that is already soaked from days of rain, in an air mass loaded with moisture, with more heavy rain falling around it and ahead of it. The exact conditions the brown ocean effect requires are being assembled along this storm's path. That is why the models are showing it survive. And this is not just a theory, because a storm has done this before, and what it did stunned the people watching. Go back to August of 2007 to a storm called Erin. Erin came ashore in Texas as a weak, sloppy tropical storm and did exactly what the rule promised. It weakened and forecasters moved on. Then, roughly 2 days after landfall, over Oklahoma and hundreds of miles from any ocean, Erin did the impossible. It reorganized, it deepened, its winds picked back up, and it developed a clearing in its center that looked, on radar, like an eye, the signature of an intensifying hurricane, except this one was spinning over the dry plains of Oklahoma in the middle of the night. It produced damaging winds and heavy rain far inland, and it forced scientists to take seriously the idea that the ground itself can bring a dying storm back to life. Erin became the textbook case for the brown ocean effect. Set it next to Arthur, and the pattern is hard to miss. A weak storm, wet ground, a saturated tropical air mass, survival where the rule demands death. The difference is that in 2007, the comeback caught everyone by surprise. Today, the models are flagging the possibility days ahead because storms like Erin taught us what to look for. That is the strange gift of these events. Each one that cheats death teaches us how the next one might. And Arthur may be about to do something Erin never did on the far side of the country. If the brown ocean explains how Arthur survives the trip across land, a different mechanism takes over when it reaches the East Coast. As the storm approaches the Carolinas later this week, an accelerated ribbon of jet stream winds is forecast to dive south and position right over the top of it. That matters because of something called divergence aloft. When fast winds high in the atmosphere stretch across the top of a storm, they pull air out of the top of the column faster than it can be replaced. Remove air from the top, and the pressure at the surface drops. Falling pressure is the definition of a strengthening storm. So the jet stream acts like a hand reaching down and pulling the storm open from above, lowering its pressure and re-energizing the circulation. Just as the system reaches the warm shelf waters off the southeastern coast and gets real ocean fuel again. Saturated land keeps it alive across the south. The jet stream reloads it in the east. The warm Atlantic finishes the job offshore. 3 mechanisms, handed off one to the next, carrying a storm that should have died days earlier. Watch what the storm is doing even before it reaches the coast, because it ties the whole picture together. Right now, with the center still inland, Arthur is throwing its moisture far out ahead of itself, exporting tropical air downstream toward the eastern seaboard. That moisture is not wasted. It wets the ground that becomes the brown ocean, and it primes the very region the storm is heading toward. In effect, the storm is building the road in front of itself, soaking the ground it will later cross, and feeding the rain that will arrive ahead of its center. A tropical system is supposed to be a candle that burns until the warm water runs out. Arthur is behaving like a candle that keeps finding new wicks, and it can only do that because the atmosphere around it is willing to hand it fuel at every step. To be precise, by the time Arthur reorganizes off the Carolinas, it may no longer be a purely tropical system. It may be a hybrid, drawing energy partly from the jet stream and temperature contrasts rather than ocean heat alone. But for anyone on that coast, the label barely matters. Forecasters have already said that tropical storm watches or warnings could become necessary along the Carolina coast late this week if this scenario holds. The wind and the rain would feel the same regardless of what we call it. And the rain is where this story stops being a science curiosity and starts being dangerous. The danger from Arthur is not the wind, it is the water. A storm this week does its damage through rain. The reason this rain is so serious comes back to the same overloaded atmosphere keeping the storm alive. The Weather Prediction Center has placed the Gulf states under a moderate risk of excessive rainfall, a level 3 out of 4, with widespread totals of 2 to 5 inches, and localized amounts of 6 to 9 inches across southern Alabama, the Florida Panhandle, and parts of southern Mississippi. When that much rain falls on ground that is already saturated, it does not soak in. It runs off, and it rises fast. There's a coastal piece to this as well. Along the immediate Texas and Louisiana coast, forecasters expect a storm surge of 2 to 4 feet around the times of high tide, with coastal flood warnings and advisories already in effect. That surge is not catastrophic on its own, But it becomes dangerous when it teams up with the rain. When the sea is pushed up against the coast at the same moment that rivers and bayous are trying to drain all that runoff out to that same sea, the water backs up and the inland flooding gets worse. It is the combination, the surge meeting the runoff on already soaked ground, that turns heavy rain into a genuine flood emergency. And because the brown ocean effect keeps Arthur alive longer, it keeps that rain falling over more ground for more hours than a normal weakening storm would. Here's the part people get wrong every year. When a storm is weak or weakening, people relax. They see a tropical storm instead of a hurricane and they tune out. But some of the deadliest tropical disasters in American history were not powerful hurricanes. They were weak, slow, rain-heavy systems that parked over an area and drowned it. The water does not check the category before it rises. And Arthur is not even going to weaken on schedule, which means it keeps producing rain for longer, over more ground, than a normal inland storm would. There's one more trap. The storm is already throwing its moisture far out ahead of its center, a pattern related to what forecasters call a predecessor rain event, where tropical moisture floods a region well ahead of and to the side of the storm itself. So the forecast cone, the one everyone watches, is misleading here. The cone shows only where the center of the storm goes. It says nothing about where the rain falls, and the rain is going to fall far beyond that line. If you are anywhere from Louisiana to the Carolinas, watch the water, not the wind, and never drive into a flooded road. And the water is not the only hidden hazard riding inside the storm. Tropical systems like Arthur carry a second threat that almost nobody sees coming because it looks nothing like what people expect. As the storm's rain bands move on shore, they drag a lot of low-level spin into the atmosphere, and that spin can concentrate into small, fast circulations inside individual cells. These are spin-up tornadoes, and they are not the visible funnels of the Great Plains. They are small, they are wrapped in rain, so you cannot see them, and they form with almost no warning. Forecasters have flagged exactly this threat across the Deep South, a marginal risk with a tornado probability around 2% that could be nudged toward 5% as the storm comes inland, stretching from Louisiana, across Mississippi, Alabama, the Florida Panhandle, Georgia, and eventually toward South Carolina. The probabilities sound low, but weak tropical systems can produce these tornadoes in bunches over the days they take to cross land. And the detail that matters most is timing, because the peak threat often comes overnight, when people are asleep and a warning measured in minutes is hardest to act on. If you are in that corridor over the next couple of days, make sure you have a way to get warnings that will physically wake you up. The spin-up tornado is the part of Arthur nobody's afraid of, which is exactly what makes it dangerous. And it is also a clue to something much bigger happening across the country. Arthur is not happening in isolation. Yesterday, at the same time this storm was breaking the rules over the Gulf, a violent tornado outbreak was unfolding 1,000 miles to the north, across Illinois and Indiana, and the two are connected. The Storm Prediction Center had placed parts of that region under a level 4 out of 5 risk, with the potential for strong, long-track tornadoes, damaging winds over 75 miles an hour and hail the size of baseballs, all from a setup that belongs to April, not the middle of June. The reason both events are happening at once is that they share an engine. A low-pressure system far stronger than mid-June should allow, dropping toward around 990 millibars, has been tracking into the Great Lakes, paired with a jet stream more typical of late winter. On its southern flank, that system drags warm, wet air northward out of the Gulf. That surge fuels the violent storms in the Midwest, and the same moisture conveyor is loading the Deep South with the saturated air and soaked ground that Arthur needs for its brown ocean. The very same trough is the one forecast to dive over Arthur near the Carolinas and reload it. So these are not two separate stories. They are two faces of one enormous, overloaded pattern. The tornadoes in the Midwest and the rule-breaking storm on the Gulf are drinking from the same well. The atmosphere is carrying so much energy and moisture right now that it is handing fuel to storms everywhere it can, in the violent updrafts of the Midwest and over the soaked ground of the South. The reach of this single pattern is hard to overstate. As the cold front tied to that strong low sweeps east, the severe weather threat does not end in the Midwest. It marches into the mid-Atlantic and the Northeast, with forecasters watching a long corridor of major cities for damaging winds. At the same time, Arthur's moisture spreads flooding rain across the Southeast. Add it all up, and one connected pattern puts well over 120 million people, more than a third of the country, under some kind of severe weather threat. That is the scale we are talking about, and Arthur is the part of it that happens to be breaking a famous rule, which is exactly why it is worth understanding what is really feeding it. And that raises the obvious question: why is the atmosphere this overloaded in the first place? The answer is in the water Arthur came from. Trace every part of this back far enough, and you arrive at the same place, the warm water of the Gulf of Mexico. The Gulf is running hot, and it is running hot months ahead of schedule. The Atlantic season only began at the start of June, and the first named storm has already arrived and is already defying the textbook. That early start is a sign the basin is primed well ahead of the calendar. The warmth also runs deep, which matters more than most people realize. A storm churns the water beneath it, dragging up whatever is below. Over a thin layer of warm water on top of cold, the churning quickly cools the surface and starves the storm. But over a gulf that is warm well below the surface, the churning just brings up more warm water, and the fuel keeps flowing. A gulf this warm, this deep, this early is not just a full fuel tank. It is one that resists being emptied, which is exactly the condition that lets a storm form early and hold together longer. Behind that sits a broader climate signal with the Pacific in a neutral but warming state, and the key index sitting around plus 0.48 and climbing, helping set the overheated pattern across North America. Then there is the simplest physics of all. Warmer air holds more water vapor, roughly 7% more for every degree Celsius of warming. That is why the moisture ahead of Arthur is running near record levels for mid-June, between 2.1 and 2.6 inches of precipitable water. A warmer, thirstier atmosphere is a loaded one, and a loaded atmosphere is the precondition for everything strange happening this week, from the rule-breaking storm to the flooding to the out-of-season outbreak. Which is also why, whenever a storm behaves this strangely, people start looking for someone to blame. Whenever a storm does something that looks impossible, the theories start. Already there are claims circulating online that Arthur is being steered or artificially strengthened, that some technology is making it behave this way. The instinct is understandable because the storm is breaking a rule everyone thinks they know. But the science answers it cleanly. The behavior is fully explained by the brown ocean effect and the diving jet stream, both documented, both real. And the energy involved makes the conspiracy impossible on its face. A tropical storm releases energy on a scale that exceeds anything human technology can put into the atmosphere by billions of times. You cannot steer or fuel a storm with tools that operate that far below its own power. Nobody is controlling Arthur. There is, however, a real scientific question underneath all of this, and it is worth stating honestly. The genuine debate is not about steering storms, it is about loading dice. Scientists are actively studying whether a warmer Gulf and a moisture-loaded atmosphere are shifting the odds towards storms that form earlier, carry more water, and resist dying over land. That is an open research question, not a settled conclusion, and it deserves to be treated as one. The conspiracy imagines a hand reaching into the system. The real question asks whether the system itself is changing, and that question is exactly why what Arthur does over the next few days matters so much. Here is what to watch. Over the next 2 to 3 days, the key test is whether Arthur really does hold together across the deep south and then reload off the Carolina coast. If it does, and if tropical storm watches go up along that coast late this week, you will be watching a storm complete one of the strangest journeys in tropical meteorology, alive on the far side of the country days after it should have died. The flooding threat is the immediate danger, spreading across the southeast on already saturated ground, with the spin-up tornado risk riding inside the rain bands, especially overnight. The bigger picture does not end with Arthur either. The same overloaded pattern is already setting up the next round, with a fresh, severe weather threat taking shape over the central plains this weekend and the heavy rain across the southeast refusing to quit. The atmosphere is stuck on repeat, and the largest question sits at the end of all of it. This is the first named storm of the season in the supposedly quiet part of June, and it is already doing the impossible because the Gulf is this warm this early. The hurricane season runs for 3 more months into the part of the calendar when the ocean is hottest and the biggest storms form. If the opening act is already breaking the rules, the real question is what the rest of the season has in store. We will be tracking it as it develops.